Don't leave her alone.
That's fine.
All right, hello everyone. So we are lucky enough to have some guests today from our Ontario Tech Space and Rocketry design team. And so they'll be giving us a presentation and also be able to answer some questions later. So I'll give the floor to you guys. Take it away.
Hello, everyone. It's nice to see all of you and the ones who are online. So my name is Ellie. I'm a general member of the outreach team.
I'm Chris. I'm the lead for the software team.
I'm Luke. I'm the outreach lead for the Rocketry and Rover team.
I'm Jim. I'm the team manager of the Rocketry.
I'm Eric. I'm the team manager for the Rover team.
And we're some people from Ontario Tech Space and Rocketry. So we're going to talk to you a little bit about what we do and what kind of projects we work on. So who are we? So we're a design team that focuses on creating high-powered rocketry and basically shooting a giant rocket into the sky, usually hopefully faster than the speed of sound, and we hope would go to at least 60,000 feet. Also during this, we try to perform research within it, and we often do some type of nuclear research within it or see how we can test our rocket and how we can design things. And it's usually a student design team. So students, for example, we're all students and the rest of our team is also students. And we try to get faculty in from engineering all the way to like business and education who can help out and create such cool rockets. So these are our missions. Basically, in our time, we've been able to develop 3 high-powered rockets and competed with them. So we have the OTM K1, which was our first one, kind of what we generally developed to really show if we could become a design team. And slowly as it's gone on, we've been able to improve and lead to achieve better goals throughout our competition. So we'll explain a little bit about what were these rockets as we go through them.
So the team was founded back in my first year in 2022 and started in 2023 with our first launch was OT Mark 1. OT Mark 1 was a very basic flight. As you see, like 11,200 feet is very typical for a high-powered motor. And the main goal was just to see if we can essentially launch a rocket in a year. And it was a small group of people. I think it was about 12 to 15 members originally on the team. That spent about 8 months building this. OT Mark II, we expanded the team a lot. I think we went from 15 to about 50 members. Generally, the design of the rocket was relatively the same. It was a single motor doing dual deploy, so there was 2 parachutes to be deployed. And the goal was simply to double our altitude. So I think we had a set goal of 20,000, and we just barely didn't make that with 19,774. A big important note was our first rocket we launched never ended up being recovered properly due to some failures with avionics. And this was also our first successful recovery as a team. And our really first successful competition, I think we came 6th place that year. And then OT Mark III, normally for rockets, they start off on the basics pad. You have typical launches, doesn't really get super complex. OT Mark III was our first rocket on the advanced pad because it was a 2-stage, meaning midway through flight, it broke apart and then a second motor would carry it up. It was definitely a very hard design with a projected altitude of close to 50,000 feet. It was like 47,000. However, due to some errors in the aerostructural design, we actually only ended up having a maximum altitude of 19,000 feet and mostly recovered it in pieces. And next year, we hope to kind of remake up for that fact, continuing on the advanced pad.
All right, so Launch Canada is the event that the Rocketry team goes to. Basically what it is that we compete against multiple teams across Canada. So we've competed against universities in British Columbia, Alberta, Saskatchewan. I believe there have been some from Manitoba and Nova Scotia as well. But the main goal of the event is not simply for competition. The main goal is basically get the name out there. So for most people here, and I guess online, if you're able to, if you think of going into a space industry, what's the first one that comes to mind? Because I'm going to assume that it's not the Canadian Space Agency. I'm assuming you're thinking something like NASA or SpaceX or Blue Origin maybe. But the point is that when we think space and rocketry, we don't think Canadian space and rocketry. We think, oh, let's go work in America. So the whole point of Launch Canada is sort of get the word out that people want to build this stuff in Canada. People want to work in these areas in Canada. So we both have a conference at the start of the event that's usually the first weekend or so to sort of introduce all the teams and have sort of workshops and mini lectures from people that are currently working in the industry, such as we've had people from MDA Space talk before, and we even have some lectures from other teams about what they're developing. After that, we have about a week where we're able to launch our rockets that we've been building for the entire year. Now, this is usually in August, so we usually have the entire school year plus to work on it. But yeah, about every time, about the second week in August, we have about the weekdays to sit down and, or I guess, get to the launch pad and go launch our rockets. And then finally, at the end, usually on, I want to say the Friday, at the end, we have sort of a final celebration to sort of, again, celebrate the fact that space and rocketry exists in Canada, but to also, you know, have awards for who flew nicely, who didn't, sort of some jokes at the end, you know, all the good stuff.
So these are, if it will play, it might not play, but we do have videos of our launch going up within the sky. Sadly, the videos won't play this time, but they're pretty cool. And you can see it on our social media too, if you wish to check it out. So our future.
Moving on to OTMK4. The idea is to do a 2-stage rocket and do it successfully. We're also going to change up some of the diameter to start standardizing our payload sat. On top of that, we're also moving into a hybrid engine program. If we're very lucky, we'll be doing that static fire at Launch Canada. On top of that, we're also delving into using a 3D metal printer for some liquid nozzle designs, which is kind of cool. On top of that, trying to get our name out there more within the high school region and stuff with outreach. But I mean, for us, doing something successfully is more important than just doing it. So because we failed with the 2-stage, we're looking at actually doing it completely from start to finish to recovery. On top of that, we're going to be developing more of our actual standard stuff that we're going to need no matter the size of rocket and stuff like that, like protocols and homing beacons and stuff that makes our lives easier. But in that regard, I mean, the system itself will be the same, and probably try to develop ourselves a bit more.
So those are generally our goals. One of our really main goals is, as well as within outreach, is like events like this. Some of you might be high school students or younger students as well in elementary school and might want to get into rocketry. And here with OTRS, we hope to create really fun workshops for you all to develop your skills and learn how to build rockets and see what that's like and to create your own. I know I've had personally the experience to make my own little miniature model rocket, and it's been so much fun. And I think for kids specifically, it's such a cool experience. And so that's another big goal that we have within this team. And through that, we also, to create all these goals and achieve this, we have all of our departments. So we have different departments going all the way from aerostructures, avionics, payload, software, recovery, and propulsion. Those are very much more of our technical departments, but we also have kind of our non-technical like outreach, which is doing things like this, or our marketing and business, which allows us to get things like funding, but also just promote what we're doing as a team. So all these little things are different ways that us as students can get involved within this team and how we can kind of learn more and develop more skills, especially as university students within this space.
So new this year, we are not only doing rockets, but we have started a rover division. We have dubbed it Ontario Tech Operations on Planetary Surfaces. So with this, we are looking to compete in the Canadian International Rover Challenge. This is a new frontier for us to explore and to explore more than just rockets, actually get into space along with our CubeSats and other such programs that we're in development of. So CIRC is the Canadian International Rover Challenge. It takes place at the very start of August, right ahead of Launch Canada. It's located in Alberta in the Badlands. They also do a winter competition held in Niagara Falls. So with that, they have set out our rule set where we have to build a rover that is less than 50 kilograms or 110 pounds. Basically, it has to be able to get carried by 2 people in case stuff breaks. And it's got to be able to operate in all the weather conditions. They do not stop the competition if it's rain or sleet or snow. There are a variety of tasks ranging from 1 hour to 3 hours. There's also a 2 kilometer range that we have to navigate through. So in that, we have to create some rather robust systems to be able to survive. There are some armed dexterity tasks to test that part out, along with some search and rescue style stuff.
And yeah, so that's what OTRS is plus Rover. As of now, if you are an Ontario Tech student and maybe you're interested in joining, we do have recruitment open. And if you're possibly thinking of becoming an Ontario Tech student, we're a great team to join, and it's a great experience. So if you are interested, we do have this QR code here, and we do have for Rover too, which all have open recruitment as of now. If there are any questions, we open the floor.
All right, not all at once.
Do you guys have, like you mentioned, you have outreach program for the elementary students as well?
Yes, yeah. And it depends on what it actually is, but Luke might be able to answer that a bit.
Yeah, so the big thing is with the outreach workshops is mainly what we do is we reach out to, like, we only have connections with places we've been before. So we've been reaching out to high schools that we've been to, elementary schools. We're currently working on sort of ideas where, like, we can do workshops or we can go and teach, but we're currently working on a more tactile and practical workshop. Right now we have some ideas, but we're not entirely sure, but yeah, for elementary workshops, we can definitely do it. That's the most.
There's also the content detail for.
Yeah. There's also a big one at Moonshot at November 6th, which is in Burlington.
That for which, like.
Just in general, it's just an event.
Yeah, it's mostly it's high school students, but it is usually open.
And you have the normal listings?
Yeah.
And I can get it.
You can look it up. Yeah, I
Yeah.
can help you out. Something, it's a cool event.
What changes did you make from your OT Mark 1 to 2 to get the higher altitude?
From 1 to 2?
Yeah.
He can answer that better.
A large part was definitely motor class. I forget the exact motor we used for OT Mark 1. For OT Mark 2, we used N-class motor, which is going to be, I think it was 5,700 newtons of force. Definitely that's the main, when you think of a rocket, you have thrust, you have drag, and you have gravity. Those are your 3 pretty much only forces that are happening. Yeah, really just thrust class, and then you have to actually increase the size by a fair margin to hold larger motors. Other than that, I forget if OT Mark 1, was it single deploy or I'm pretty sure it was dual deploy. Yeah, that was really the only change. It kind of kept a lot of the same design principles. It was more like a retake because we did end up losing OT Mark 1.
It was also less mass. We added more power and removed a lot of weight.
Yeah,
So it was smaller as well.
because I think OT Mark 2, how much was OT Mark? OT Mark 2 was like 56 pounds. OT Mark 1 was maybe.
I know we lost it. I know we lost a couple feet between 1 and 2.
It's really, you can't really do much between those two to.
Kind of the same thing from 1 to 2, where it's like until you get it perfectly, just keep going, right? Failure is part of the whole idea. I mean, it's not surprising to hear that in the space industry. So kind of just what you learn from mistakes or from things that you weren't planning on is so much more beneficial than having everything work perfectly sometimes.
The other thing too is the silver lining as well. The physics don't change. It's not like we have to wait for something to happen to make Mark II fly higher. It's just take what we learned from the previous one and apply it to what we already know and get Mark II.
That's it. What kind of sensors did you use in your Mark 3?
Mark 3, a lot of it, we use pretty much all commercial stuff. A big thing was we tried egg finders. It's like pretty much the cheapest you could find on the market and almost exclusive to Rocketry. Those were like the altimeter sensors. So they just track, I think they have barometer. So it's like barometric pressure, gyrometer, a couple other different things that I won't get into today. But essentially just tracking exactly where it is and how much pressure is being intaken. And then it allows you to determine when you'd be at apogee, so you know when to deploy parachutes, and you use that. Also, like a GPS tracker. For OT Mark, you said three. For three, we used we originally were going to use the egg finders for tracking, and then we switched to some featherweights that another team lent us. The avionics kind of messed up in the end. We were originally going to use egg finders and then Telemega. You've heard of that brand? They're pretty niche brands in terms of rocketry. I know you really want something that can work very long distance and very compact and lightweight. So you're not really going to see like household names in terms of like tracking for that kind of stuff. And then we've been looking into for a while and designing our own chips, like custom boards for both radio, telemetry, storage of everything, like a whole bay that has stacked chips to work as a system because a lot of other teams do have.
Using a standardized CubeSat design of 2U. And basically the idea is whatever other teams do, there's a reason for it. And it helps you for payload know exactly what sizes they're going to be using year to year to year. And lets you kind of expand off things. Or if you can carry over from year to year and you know that you don't have to redesign it from scratch each time.
One thing I would say, if you're interested in anything, for my personal project stuff with relating to rockets, I've done like you get an Arduino, you wire that to like some sort of whatever sensors you want, and it's a very simple program to actually create some of your own altimeters, some of your own boards, without getting into like really advanced technical ideas. Took me before that, I really never soldered in my life or knew anything about electrical, and it took me about like 3 or 4 days, so it wasn't bad at all. It worked out really beautifully. So yeah.
Yeah, whatever else.
Any other questions? No? Well, thank you everyone for your time. If you ever see any of us around, we'd be happy to answer maybe any more questions, but you can keep active on whatever we're doing in terms of social media. We've been pretty active there, and we like to continue to host events, or not host events, but present events like this and even other events if you want to see us anywhere else on campus. Yeah.
Yeah.